All right, then we will start our notes here for section 4.1. All right, we are going to start working with systems of equations. And the ones we're going to work with today are two equations with two variables. Now, systems of equations can actually be much more than that. You could have three equations with x, y, and z, three variables. It's just a matter of how many things we are working with. So to start with, we are just going to do two equations with two variables. And our solution will be in the form x comma y. So I always go alphabetical order. If it was A and B, I would put A, then B. If it's M and N, I would put M, then N. We have three methods that are most commonly used in algebra to solve these. The first one is graphing. The second, substitution. And the third, elimination. There's a fourth one that are matrices that we will talk about on Thursday. So that's the next section. That's in 4.2. All right, we can get three different potential answers. Option one is we have one answer because what we are working with right now is we are working with linear equations. So two variables, two equations means we have x, y coordinate plane. We've got two lines that are somehow on this graph. And if they cross, they can cross at one specific spot. Okay, so this is if the lines cross. The second option is there is in fact no solution. There is no way to make those two equations equal at a specific point. So what happens in this case is we have parallel lines, and these parallel lines don't ever intersect. So because they don't ever intersect, they are never equal, they're never equivalent, so we do not have a solution. The last one is when we have infinite solutions. And what happens here is the equations are disguised, but they're identical. So when you look at them, they don't look identical. They don't both say 2x plus 5y equals 10. One is multiplied or divided by a number so that it looks different. But what happens is the lines are in fact identical, and they end up overlapping each other. They fall directly on top of each other. So no matter what I plug in for x, it's going to work because the two lines are equivalent. All right, we are going to start with substitution. And substitution, what you do, am I doing substitution? Or am I doing, hold on, let me double check. Nope, I'm doing graphing. Double checking my notes here. We are going to solve these first ones with graphing. Okay, so when we do graphing, if you have a graphing calculator from like high school, you can bring that, you can use that. Otherwise, I just go to desmos.com and I open their lovely graphing calculator and I can type this exactly as it is. If you have the TI calculator, you would have to have them solve for Y. So sometimes just going to Desmos is easier because I can have it written in any form and it doesn't matter. I'll be able to enter it in. Okay, so I'm literally just going to copy the exact equation. X plus Y equals 4. And it's going to color code it. And then when I put another one in, 2x minus y equals 2, it's going to give it another color. And then you can see on the right-hand side, these two lines are in fact intersecting. So the goal is to determine where they do in fact intersect. So all I need to do is click on one of the lines and you see that little point appear. I then click on the point. It makes it bold and it tells me what that exact intersection is. So these two lines will be equivalent if I plug in 2 for x and 2 for y. So that is our solution. Did you type it in exactly as it says here?
Oh, no, I didn't. I'm sorry.
Okay. I can always come around. But we should all get the same answer when we graph these. I'm going to try to shrink this down a little bit here. If you don't want them, you have two options. One is you can X them out, or two is you just uncheck it from here. You uncheck this side, it's saved. It's just not graphed. Otherwise, you can just click the X's and it deletes it out. So next one, 6x minus 3y equals 9. 3y equals 9. There we go. 2x minus y equals 3. Okay, so look, if I uncheck the purple, the green appears. So the purple is appearing directly on top of the green, means these are identical equations. So what I said is when you look at them initially, they're not going to look the same. However, if you think about this, this top one is exactly 3 times everything in the bottom. So 3 times 2 gives me 6, 3 times 1 gives me 3, 3 times 3 gives me 9. So the one is always a multiple of the other. And that is when you have identical lines. And you would say there's infinite solutions. Infinitely many, however you want to write it. Then slide this over here. Oops. Oh, I didn't want to. Oh, I don't want to split screen. There we go. All right, so if I clear those out, 2x minus y equals 4. 6x minus 3y equals negative 18. Okay, so if I look at these, it looks like they're parallel. And I can zoom out and they are for sure parallel. Okay, they're not going to touch no matter how far out I zoom in or out. So they're never going to intersect, means we have no solution. All right, so if we are asked to solve by hand, we have two methods here. Substitution and elimination is where we're going to start. And then on Thursday, we will talk about matrices. So in order to do substitution, you have to either have one of your equations already solved for a variable, or you're going to solve one for a variable. Generally, the way that has always been done, graphing was always the best when they were both in y equals form. Substitution was always the best method when one was solved. That was always the quickest method to go to. And then elimination is when neither of them are solved, they're both in standard form, was usually the best method to choose. It was the quickest method to get your answer. It didn't involve any extra steps. Okay, so with substitution, we want to have one equation solved for a variable. If that is solved for a variable, so here, y equals 2x minus 3. I can take that 2x minus 3 and I can put it in y to the other equation because it's telling me that is what y equals. So I am taking what y equals and substituting it in to this other equation. So x plus 2, in place of y, I am putting 2x minus 3. And then still setting it equal to 14. And then from here, we are just solving like we solved last week. So I have to distribute the 2 into both pieces. X plus 4x minus 6 equals 14. X plus 4x is 5x minus 6 equals 14. I can then add 6 to both sides. I get 5x equals 20. When I divide by 5, x equals 4. Now, I'm not done yet because this involves two answers. I need an answer for both x and y. So what I'm going to do now is I'm going to take this value that I got here, x equals 4, and I'm going to bring it back up to that initial equation and plug it in for x. So we know that y equals 2 times x minus 3. So y equals 2 times 4, because that's what x equals, minus 3. Well, 2 times 4 is 8. 8 minus 3 is 5. So final answer, 4, 5. Guys remember doing this? Okay. So in the next one, we have 2x plus y equals 6 and x minus y equals -3. So in this one, neither of them are actually solved for a variable. So what I have to do is I have to do one step to one of the equations to be able to determine how I'm going to solve. So what I like to do is I like to look for the variable that is by itself, like no coefficient. So I could, in the top equation, I could solve this for y. Or in the bottom equation, I could solve for x, because neither of those have a coefficient. It really doesn't matter which one you do. It's really preference. I'm going to take the bottom one here, and I can solve it for x if I just add y to the other side. So x equals -3 plus y. So I'm going to take, that -3 plus y, put it in for x of the other equation. And the key is you always have to make sure you put it in the other equation, the one you didn't work with. So instead of writing 2x, we're going to write 2 times -3 plus y equals 6. Now we'll distribute. So -6 plus 2y plus y equals 6. Combining like terms, -6 plus 3y equals 6. If I add 6 to both sides, I have 3y equals 12. And then divide by 3 to get y equals 4. So we're halfway there. We're now going to take that y equals 4 and plug it back in up here to find what x equals. We said x was -3 plus y, so -3 plus 4 is 1. So final answer, 1 for x, 4 for y, 1, comma, 4. Oops, I just drew through my 1. Okay, are we good with this? Do you want me to do a third example? Yes, you want to see a third one? Okay. All right. So 3x minus y equals 7. 2x plus 3y equals 1. The only variable that is remotely close is this guy up here, this minus y. So I'm going to try to get y by itself. It means I need to get rid of this positive 3x. So what I'm going to do is I'm going to subtract it to the other side. So I have -y equals 7 minus 3x. Now my problem is, though, that this says -y equals this. And I have to have a positive value. So all that means I have to do is I'm just going to multiply through by -1, and then it's going to get rid of that negative in front of the y. So that now becomes y equals -7 plus 3x. All that I'm doing is changing all the signs. So I can change a negative to a positive to a negative, a plus to a minus, minus to plus. And then we have everything ready to go to take -7 plus 3x. Now you can't see that. It's underneath there. Let's not do highlighter. Let's just pick another color here. And we are going to take that. It's equal to y, so it's going to go in place of y in the other equation. So 2x plus 3, I'm not going to write y. I'm going to write -7 plus 3x equals 1. The key with substitution is once you plug it in, you're going to distribute, combine like terms, and then solve. So if I distribute that 3 in, I've got 2x. It's going to make -21 plus 9x equals 1. So if I add 11x minus 21 equals 1. I'm then going to add 21 to both sides. So I have 11x equals 22. And then when I divide by 11, I get x equals 2. We take that value back up to the top, where it says y equals -7 plus 3 times x. So y equals -7 plus 3 times 2. 3 times 2 is 6. -7 plus 6 is -1. So final answer is 2, -1. All right, so the next method then is called elimination. This was always my preferred method. I just felt like it was generally faster than substitution, but in the end, it's preference. So with elimination, your goal is to match either an X or a Y term, but have opposite symbols. So when I look at this first problem here, I've got 3u minus 2v equals 12 and 7u plus 2v equals 8. So if you look at the v's, it's -2v, +2v. They're the same number in front, but opposite signs. 2v, -2v. Because with elimination, what you can do is you can treat this as a stacked addition problem. So all I now need to do, if I already have the opposites here, I'm just going to straight add. So 3u plus 7u is 10u. Well, why am I adding? Well, because -2v and +2v cancel out. They're gone. So then I'm left with 12 plus 8 is 20. And I've already got my answer for u. Divide by 10, u is 2. Now I'm going to plug that back in. Pick your option, first or second, it doesn't matter. So 3 times 2 minus 2v equals 12. What does that give me? 6 minus 2v equals 12. So I'm going to subtract 6 from both sides. Generally, I don't like the -1. I don't know why I picked this one, but whatever. -2v equals 6. If I divide by -2v is final answer -3. So u alphabetically is before v, so 2, -3 is the final answer. I just feel like when I did that, that was faster than substitution. So it was the one that I always like to choose. It's really, in the end, preference. It doesn't matter if Pearson tells you like, hey, solve it with this one, because it's just going to ask you for the answer. The only time it may matter is if I specify like on a quiz or test, like, hey, solve it with this because I want to see the work of how you do it. Otherwise, it's totally choice for which one you want to do. All right, next one here. We don't have anything matching. So I've got 2x plus 3y equals 1, 3x minus y equals 7. So nothing is currently matching, but I already see my y's are opposites. One is plus, one is minus. So what I can do, so this one, it was set up ready to go. This one, you only need to work with one equation. Multiply one equation. So I can take any equation and I can multiply it by a number, I can divide it by a number. As long as I do it to every single piece in that equation, it is still equivalent. It is okay to do. So I can take this second equation, and if I multiply this bottom equation by 3, I get, not 3x, I get 9x minus 3y equals 21. Now, the biggest mistake I see when people do this is they forget to multiply it to that end one. They do 9x minus 3y and they leave it still with 7. So just make sure you multiply, distribute it into every single piece. I'm going to keep the top as it is because now my y's vertically stacked are exact opposite of each other. Positive 3y, negative 3y. So I'm ready to do my addition. My y's are going to be gone. So 2x plus 9x is 11x. 3y minus 3y gone. See you later. 1 plus 21 is 22. Divide by 11. And I'll get x is 2. And then you take that, take your pick, it doesn't matter. So 2x plus 3y equals 1. I'm going to plug in 2. So 2 times 2, that's 4. 4 plus 3y equals 1. Subtract 4. 3y equals negative 3. And then when I divide by 3, I get y is negative 1. So final answer is 2 comma negative 1. Anybody still writing that down? Okay. All right, third option. Nothing's ready to go. What I'm going to have to do is multiply both equations. So multiply both. So I look here, I've got 6x minus 2y equals 4, 5x minus or plus 3y equals 8. Generally, again, I still tend to go towards the ones that are already opposite signs so that I will be able to just vertically add once I multiply. So I've got 2y and 3y. So the quickest way to do this is you multiply by the other. So I would multiply the top by 3 and the bottom by 2 if I wanted to cancel out the y's. If you wanted to work with the x's, so just sidebar here, if I wanted to work with the x's, I chose the y's because the signs are already opposite. Okay. If I wanted to work with the x's, I would multiply the top one by 5, the bottom one by 6. The problem is at that point, I would have 30 and 30. So then I would subtract. Or the easier way to do it is multiply one of these by a negative so that you don't lose the fact that you're subtracting them later. So again, this is a little more labor involved because you don't already have those opposite signs. Will you end up with the same answer? Yes, as long as you follow all algebra rules correctly. Okay, so it's truly preference. The quickest way, like I said, is always just multiply by the opposite one. You can always find the least common multiple, and sometimes it's not multiplying by the other one. It doesn't matter what you multiply by, as long as the end result is you have a number and it's exact opposite down here. I could multiply them up to 120 for all I care. It doesn't matter. larger numbers, going to be a little more algebra intensive, but it will still work. All right, so I'm going to go back to this one on the left-hand side just because the y's are already lined up. Okay, multiply by 3, everything by 3. 18x minus 6y equals 12. Okay, multiply everything by 2. 10x plus 6y equals 16. Then we're going to add. All right, so we have 28x, no y's, equals 28. So x equals 1. I can then take that back here. Let's use the bottom one for this time. So 5 times 1 plus 3y equals 8. 5 plus 3y equals 8. Subtract 5. 3y equals 3. And y equals 1. 1 comma 1. So just to show you, you don't have to write this down. Negative 30x, positive 10y, negative 20. 30x, 18y, 48, 28y equals 28. So y is again 1. And if y is 1, then I'm going to plug it back in and I'm going to get the other answer. The only thing, like I said, to be careful with if you're multiplying here. So if you did it this way and you didn't multiply by the negative, the problem is that it gets tricky if you're going to write minus. Just because I know it generally leads to more errors where people forget, like, oh, I'm subtracting. 30 minus 30 is 0. Negative 10 minus 18 is negative 28. It's just a little more messy when you're subtracting versus adding. That's why I like to multiply by the negative up there instead. So it'll all work. No matter how I do it, I'm going to get the same answer as long as my algebra is correct. Make sense? All right. Word problem. A company markets exercise DVDs that sell for $19.95, including shipping and handling. The monthly fixed cost or advertising, rent, etc., is $24,000, and variable cost for materials, shipping, etc., is $745 per DVD. Find the cost equation and the revenue equation. So that's the first thing we're going to do. So we have a cost and we have a revenue. Anybody want to take a guess? Times X. Okay, so let's fill it in. What are we filling in? Fixed cost is 24,000 plus $7.45 X. Revenue. How much do I make? $19.95 per X. Okay. This is still a system of equations. We can now find our break-even point. So what we were doing last class when we did these application problems was leading us into what we did today, solving basically substitution. Set one equal to the other. And find where they intersect. Now, at this point, because you know how to graph, you know how to substitute and eliminate, did I have to do this by hand here and do algebra? No. Could I have gone to Desmos and graphed both of these? Yes. So let me do this here, and then we'll go back and show you in Desmos really quick. So subtract 745x to the other side. 4,000 equals, is that 12? Is that 1250?
Yeah.
X. Okay, and then if I divide by 1250, I'm going to get to do 1,920, I believe. Okay, so if I ever ask you, like, what is the real world meaning of your answer? Okay, that means we must sell 1,920 DVDs to break even. So if I ask you, like, in real world terms, write a sentence of what that actually means. Okay, could I have gone to Desmos here and graphed both of these? So instead of C and R, we're going to do Y equals 24,000 plus 7.45x and Y equals 1995x. Now for these, generally, you're going to have to zoom out to be able to see both equations. All you got to do is click on one of them. You'll see that point where they intersect is now gray. Once I click on it, it's there. If I want it to mark on the other side, I can click this and it puts it on the other side here, and I can label it on my graph. So it's kind of nice. Desmos is really flexible like this. So if I said, hey, solve by graphing on a test, this would be a great way to do that. Okay, you have both equations listed, you have both lines shown, you have the intersection marked, labeled, and there. So you would literally just take a screenshot of this and you could upload it to that question on your test and say, there's my answer. All right. Now let's talk about sausage. A company produces Italian sausages and bratwursts at plants in Green Bay and Sheboygan. The hourly production rates at each plant are given in the table. How many hours should each plant operate to exactly fill an order of? Okay, so I'm going to add my totals here. 62,250 Italian sausages and is 76,500 bratwursts. Okay, so I have two plants that I need to determine how much I'm working at each one. So those are my two variables. So I'm going to make Green Bay X and Sheboygan Y. And then you can see here, each column is then an equation. So 800x plus 500y equals 62,250. Because I make 800 every hour at Green Bay, 500 for every hour at Sheboygan, and I want to know how many hours total to get to 62,250. And I do the same with the second equation. So 800x plus 1,000 y equals 76,500. Now you can see here, I've got 800 and 800, right? So all I need to do is make one of them negative. So all I'm going to do is I'm going to go through and I'm going to change all of these to negatives. Now, whether you do that on the top or the bottom, it really doesn't matter. It would have been less negative if I did the top one, but I chose the bottom one. So let's see. 500 minus 1,000 is going to leave me with negative 500y. Not have that. Use calculator. 62,250 minus 76,500. Okay, negative 14,250. And then if I divide by negative 500, I get y equals 28.5. And we'll take that and plug it back in. Let's do the top one. 800x plus 500 times 28.5 equals 62,250. Okay, 500 times 28.5 is that 14,250. Which I'm going to subtract. Um, 62,250 minus 14,250. 800x equals 48,000. And when I divide by 800, I'm going to get 60. So the answer is 60, 28.5. What does that mean in real world meaning? I'm going to do 60 hours at Green Bay and 28 and a half hours at Sheboygan. Okay, so you've seen here, generally the ones I give you are going to give you nice answers. So if you solve something and you're getting like 2.57963 and the decimal's filling the whole screen, okay, that should be an immediate red flag and be like, okay, I did something wrong here because she's not giving me horrible answers, okay? A half hour, that's fine. 0.25, okay. But most of these should come out to be nice answers. So you guys have your first quick check, and that is this problem. Now, it is also, let me show you where it is so that you know what to do when you're done here. So we are in week 2. So it's going to be in the week 2 folder. So all I have to do is go down here and you'll see quick check for 4.1. Once you open it, you will see, well, you have to think I click like see directions or instructions first, and then it pops this up. Not the right problem. I need to put the right problem up. Sorry. I will do that in a second. I have the wrong slide. So it says 2 rental companies charge the following values for driving X miles. Car rental A charges a flat fee of $100 and then 15 cents per mile. Car rental B charges a flat fee of $130 and then 10 cents per mile. So what you're going to be graded on, 2 points to write the equations for the companies, letting X represent the number of miles driven and Y equaling the total cost. B says, what is the break-even point of the 2 companies? Show me your work. Okay, so whether that's by hand work or you're using Desmos to graph it, take a screenshot and you can upload that. And then part C is describe when it would be best to choose each one. So when are you going to choose A? When would you choose B? So you can, as you're doing it here, you can type your submission, you can write all your work on a piece of paper, take a picture of it, and upload it to Blackboard that way. Remember that quick checks are, I want you to try it first, and then group up with some other people first. Talk about your answer, make sure you agree on an answer before you post it. Now, if you honestly in the end disagree and you don't want to change your answer, you don't have to, but I want to give you the opportunity to talk about it and check it first before you just submit it. Make sense? So if you don't know how to upload like a picture from your phone to Blackboard, I can help you with that. If you don't know how to take a screenshot of like Desmos, I can help you with that. So this is what we're going to end with today. Once you are done and uploaded, you are free to go.